Recorded. A certain mass of air is compressed from 1 bar. Okay, I have written 1 bar. 0.1 meter cube. What should write here?
V1.
V1. Very good. V1 is equal to 0.1 meter cube. Next.
P2.
P2.
P2 6 bar.
6
Yes.
bar.
P2 is equal to 6 bar. Next. In a piston cylinder device, according to this equation. So what is the name of this equation?
Adiabatic, sir.
Why it is adiabatic?
1.4
Because
gamma.
1.4 gamma.
Is
Gamma.
1.4 is given. If it is more than 1.4, it is
Polytropic.
polytropic. Dear students, I will give in place of 1.4, I will give 1, just 1, just like this. What is the name of the equation?
Sir.
Nothing is there means 1 will be there, no? Always in the power. Nothing you have
Yes.
mentioned means obviously is 1. What is the name of this process?
Polytropic, sir.
Polytropic
N value.
n is equal to more than 1 irbek. Here it is 1. Nothing is there means obviously 1 is there.
Adiabatic.
Adiabatic 1.4. Here it is just
Fixed
1.
value adiabatic.
It is only 1, not 1.4 or not more than 1.4. Just it is 1, equal to 1.
Then what?
Then what? Nodi. How to find out the equation using
N P1 V1 is equal to P2 V2 N square.
here constant is given. So M is constant, R is constant, PV is not constant, pressure is not constant, volume is not constant. On the right hand side is constant. So here this is equal to constant. What is this? T stands for?
Temperature.
Yeah, temperature constant multiply by R constant value multiply by M, again you will get constant. So multiply of all three you will get constant, that is here.
Okay.
So it is a constant temperature equation, isothermal equation. Okay, I will write here PV 1.4, it is adiabatic equation. PV square is equal to constant, this is polytropic equation. PV is equal to constant, it is isothermal equation. And V is equal to T. What is this equation? Just now I showed. Just now I
Volume is equal
showed. Yeah, PV is equal to MRT. Here I am considering V only and T. The remaining is constant.
T.
This is constant. What is the name of this equation? V is equal to T for which process? No, constant, M value constant, R constant, P nu constant. Yeah, the process in which pressure is constant. What is that process called? Isobaric. Very good. Isobaric. So V is equal to T. You can apply for isobaric, not work done expression. Okay, to calculate volume or temperature. Similarly, if I write like this, which equation it is? Which process?
Isochoric.
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 Yes, very good. You have to remember these 4-5 equations. That's it. You can solve any one equation. So why you are using this equation is using this equation. P by T is equal to some constant. We can write this equation same as this equation. Mathematics. So P1 is equal to constant. P2 by T2 is equal to constant. So we can multiply left hand side. So these three values will be given. You can find out the T1 temperature using this equation. Or P1, T1, T2 will be given. We can find out T2 using this equation. In such cases, it will help you. Okay. Next. First process. Find the work of compression of air. So work done during this process is how much? Okay, but someone has told 2 process, no?
Yes,
No,
sir.
it is only one process. It is only one
Next
process. Next is, it is not continuation with the first process. First process is 1 to 2. So please read the words carefully. It is not continuation. Assume, had the compression been carried out isothermally, andre previously you are considering it as a adiabatic process, calculate the work done. So instead of adiabatic, you assume it is isothermal.
Okay, sir.
Assume it is isothermal and calculate work done and compare the values. ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ನೋಡಿ ಇಲ್ಲಿ, had the compression been ಅಂದ್ರೆ ಇಲ್ಲಿ compression ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ. ವಾಟ್ ಟೈಪ್ ಆಫ್ ಕಾಂಪ್ರೆಷನ್? ಐಸ್ ಅಂಡ್ ಅಡಿಯಾಬೆಟಿಕ್ ಕಾಂಪ್ರೆಷನ್ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ. ಬಟ್ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಅಡಿಯಾಬೆಟಿಕ್ process, assume it is isothermal between the same initial states and final pressure. Do not change these values. Keep the same values. Calculate work done. How much will be the value of work done in both the case? Okay. Now you help me to calculate work done using first condition. First condition, case number 1. There are 2 cases. Work done during 1 to 2. What is the name of the first process? Adiabatic.
Adiabatic.
What is the expression for adiabatic process? Expression
P1
for work
V1
done.
minus P2 V2 divided by gamma minus 1.
Yes, simple, gamma minus 1. Has he given P1?
Yes, sir.
Yes, P1 is 1 bar. P2?
Yes, sir.
6 bar.
Bar.
V1?
0.1.
Okay. Now V2, how will you calculate V2?
V2.
V2 is not given.
How will you
Sir,
calculate?
P1 V1 equals constant. P2 V2 is constant.
Wow. This is for isothermal process.
Isothermal process.
What is the name of the process he has given here?
Adiabatic, sir.
So something you have missed out here. ಇಲ್ಲಿ ಏನೋ ಬಿಟ್ಬಿಟ್ಟಿದ್ದೀರಾ.
Sir,
P1
1.4.
ನೋಡಿ, ಇದಕ್ಕೆ ಈ ಕ್ವೆಶ್ಚನ್ ನೋಡ್ಕೊಳ್ಳಿ, ಏನ್ ಕಾಣಿಸಿದೆ? P1 V1 to the power of 1.4. 1.4 is equal to constant. Similarly, you write at the end point P2 V2 to the power of 1.4 is equal to
constant.
Right hand side is constant. So obviously left hand side should be equal to each other. So P1 V1 to the power of 1.4 is equal to P2 V2 to the power of 1.4. So here P1 is given, V1 is given, P2 is given. Only unknown is V2. So calculate V2 using the calculator. So you can calculate V2. Okay. V2 value should be more than 1 or less than 1. V2, this V2 should be more than 1 or less than 1. And it is compression process.
Less than 1.
Less than 1. Should be less than 1 because it is a compression. I've highlighted the word compression. So V2 should be less than 1. P1, V1, V2, so we will get some value, X value, X to the power of 1 by 1.4. So we'll get V2. How much you'll get? Any idea? Let me substitute here. I will help you to substitute the value of P1.
So 0.027 meter cube.
0.027 ಬರ್ತಿದ್ಯಾ?
Sir.
Okay, let me substitute. P1 is how much you have taken?
Sir, P1, sir.
1 bar,
into
no?
10 to the power of 5.
1 into 10
Yes,
to the power of 5. V1?
0.1 to the power of 1.4.
1.4. Very good. P2?
6 into 10 to the power of 5.
10 power 5.
Okay. So calculate all these values. You will get some X value. Here X.
Yes, sir.
So do not forget on the right hand side is power. Okay. So to calculate, to cancel this 1.4, I have taken on the right hand side 1 divided by 1.4. ಈ ತರ ಮಾಡಬಹುದಲ್ಲ. X to the power of n ಇದೆ, ಇಲ್ಲಿ 2 ಇದೆ ಅನ್ಕೊಳ್ಳಿ. I need to cancel this. So what should I do? Multiply by 1 by n on both the side to the power, multiply by n by n. ಇಲ್ಲಿ n cancel ಆಗುತ್ತೆ. So x ಉಳ್ಕೊಳ್ಳುತ್ತೆ. X is equal to 2 to the power of 1 by n. ಇದೇ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಇಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡಿದ್ದೀವಿ. Okay, this is equal to x. How much will get? 0.027
027.
0.027.
meter cube. Okay, this V2 value you substitute in equation number 1. That's it. Okay, so let me substitute all the values. So W122, P1 is 1 into 10 to the power of 5, P1 is 0.1, P2 is 6 into 10 to the power of 5, V2 is 0.027. Okay, my dear student, negative value or positive value? Work done.
Negative, sir.
Why it is negative?
Compression.
Yes, because it is a compression process. You should get negative 100%. By seeing the equation also you can say it is negative because it is 6 into 10 power of 5. It is 1 into 10 power of 5. So the negative value is more. So here negative something, some value.
Minus 15.5.
Minus
Minus 15.5 into 10 power 3
10 to the power of 3 joule.
joules.
Or kilojoule also you can write. Minus 15.5 into 10 power of 5. Okay. Again calculate work done using isothermal. Second case, assume it is isothermal. Case number 2. Assume isothermal and calculate. Assume the given process is isothermal. What is the expression for calculating work done for isothermal?
P1 V1.
Okay, P1 V1 ln of V2 by
V divided by V1.
Very good. Check whether all values is given. P1 is given.
Yes, sir.
1 into 10 to the power of 5 Newton per meter square. V1 is given.
Yes, sir.
0.1 meter cube. V2 not given. Not given. V2 is also not given. P2 6 bar he has given. So will you waste your time in calculating V2 or do you know any other formula in the land so that you can write in terms of pressure ratio?
Sir, P1 by P2.
P1
by
P1
P1.
ln of
P2 by P1.
P2 by P1 or P1 by P2?
P2 by P.
Anybody?
P2 by P1.
P2 by P1.
P1 by P2.
P1 by P2. Okay, if you are okay, my dear students, so there is a confusion in always in the student's mind whether it is P1 by P2 or P2 by P1. You take P1 by P2, calculate the work done. If you got positive, assume it is wrong because it should be negative. Correct. Take P1 by P2, calculate the value of work done. If it is negative, then it is fine. If you got positive, oh, something is wrong. You have to judge your answers because in the exam, nobody will be there to help you. Okay. So it is P1 V1 ln of P1 by P2. Directly you can substitute equations. P1 is 10 to the power of 5. V1 is 0.1 ln of P2 is 10 to the power of 5. 6 into 10 to the power of 5.
Minus 17,917.
Minus 17,000.
917.
No, okay. Same. You are getting 17,000 something, right?
Yes, sir. Yes, sir.
Okay. So how much you got for same process? We have not changed the pressure volume. We are assuming it as an adiabatic. You are spending this much of work. Okay. We are assuming isothermal. We are spending this much of work. So as an engineering student, which process will you suggest out of these two for that customer? Which process will you study? You go for this process or will you suggest to go for this process? Which process is
Case
consuming less work?
Case 1.
Case 1. Yes, you have to tell it. That is an engineer duty, no? The job of the engineer is in the company, you have to say that, sir, this process is consuming only 15,000 joule of work. This process is consuming 17,000 of work. There is a difference is 2,000 joule, 2 kilojoule of work difference. So we'll suggest the customers to go for this work. Okay. Assume, my dear students, P2 is also not known. I assume P2 we don't know. So I cannot use this equation. Is there any method to calculate using the same equation? In that case, you have to find out V2. How will you calculate V2?
Sir, P1 V1 equals constant and P2 V2 is constant. sir.
Constant.
Athara.
Very good. P1 V1 is equal to constant. P2 V2 is
P2.
equal to constant. Right hand side is same. So obviously left hand side will equal. So why you choose this equation? Could you tell me why you choose this equation?
Sir, because in this temperature is constant, right? Sir?
Yes, sir. The second case is isothermal process.
Thermal.
Isothermal means we can use this equation directly. That is what I have explained to here on the right hand side. No, for 5 process I have explained here. PV is equal to constant for isothermal. PV to the power of 1.4 for adiabatic. PV to the power of more than 1.4. It may be 2, 3, 4, 5. Do not think that always it will be 2. Anything more than 1.4. V is equal to T for constant pressure. P is equal to T for constant volume. Okay, correct. So any doubts again in this numerical?
Sir, last ಅಲ್ಲಿ case toli sir.
Okay.
ಸರ್ ಅಲ್ಲಿ ನಾವು ಇದು ತಗೊಂಡಲ್ವಾ ಸರ್ ಅದು P1 by P2 ಅಂತ ಹಾಕೊಂಡಲ್ಲ ಸರ್ ಅದ್ರ ಬದಲು ಈ ತರ ಇವಾಗ ಮಾಡಿದ್ವಲ್ಲ ಸರ್ ಈಗ P1 V1 equals P2 V2.
ಮಾಡ್ಬೋದು sir, ಮಾಡ್ಬೋದು. Again, why you are investing this such much time? Anyway, data is given with easy data is given, no?
Sir.
When data is given, why you are scratching your head to calculate again unknown? If you do something wrong here, the entire numerical will be wrong. Again, you will be losing some marks.
Okay, sir.
For that reason, I said you. Otherwise, you can go ahead. No issues.
Yes, sir.